Okay, let's get into the next question. Okay, an isosceles triangle with a perimeter of 8 centimeters. Find a function that models its area in terms of the length of its base. Okay, this is a fun one. So what the question is asking us to do is, we have an isosceles triangle. Okay, let me just use my draw tool, this tool. And that will hopefully help you understand what an isosceles triangle is as well. Okay, and perfect. So what an isosceles triangle is that it has two of its sides equal. So in generally we represent them by these two equal to signs on the sides. So if we have this as the triangle ABC, we say that AB equal to AC, so the lengths are equal. So that's the property of an isosceles triangle. In this question, we're given that the perimeter is 8 centimeters and we need to find a function for the area in terms of the base. So BC. I'm gonna name these in a way so it's easier to represent. So I'm gonna call this side as S. This side will also be S because we know it's an isosceles triangle. And then BC I'm gonna call the base. Okay. So now we are given that the perimeter is 8. So the formula for the perimeter is nothing but the sum of all those sides. So we will get S plus B equal to A, or we can say 2S plus B equal to A. Now straight away the variable which we need to separate for is S, because we want our final answer to be in terms of B. So if I get S from here, I can substitute it in the next step. So what I will do is I'm gonna move B to the other side and then divide the equation by 2. So it will be 8 minus B over 2, which is equal to S. Okay. So now we will write the formula for the area. Area is equals to half base into height. So for our given triangle, if I drop a line perpendicular which is equal to the height, we need to compute what this height would be. So when a median is dropped, this intersects this side into two equal halves. So we had said that this side is equal to B, so each of the half would be equal to B over 2. So now what we can say is, to get the edge we need to perform the Pythagoras theorem, and this side was S. So according to the Pythagoras theorem, if we have the square of the hypotenuse for a right angle triangle, that is, it will be equal to the sum of the squares of the two sides. So it will be equal to h square plus b over 2 squared. So from this equation we need to separate for h, so we can substitute it in the equation for the area. So we can say h is equals to square root of s square minus b square over 4. Perfect. So we can substitute that right in. So 1 over 2 b, and then h becomes under root s square minus b square over 4. So now we need to get rid of this a square term because we need our final answer to be in the terms of the length of the base. So this is actually nothing but 4 minus b over 2. So we can use this s and then plug that in over here to substitute it. So what will that give us? So 1 over 2b is outside. Then we have a square root of 4 minus b over 2 whole square minus b over 4 square. Okay, so taking this one step further, we would have 1 over 2 square root. We know that a minus b whole square is nothing but a square plus b square minus 2ab. So that will make this 16. I forgot a b here. 16 plus b square over 4 minus 2ab. So the 2's cancel out. So that, let me just write it down so we can visualize it. So 2 times 4 times b over 2 and then minus b square over 4. So these two terms right away, we know that they cancel out because one is positive, one is negative. So we're getting closer to the final answer. So 16, these two cancel out, minus 4b. Okay, here we know that in the square root, if I take 4 common, even though this up till here is also correct, but something which we can do to further simplify is if I take 4 common, if I write this as 4 minus b, that is also correct. And based on taking this 4 common, what we can say is that under root of anything times anything, if this is a perfect square, we can actually take it out. So 4 has a perfect square, it's a perfect square of 2, so we can take out 2 from the square root. And that will cancel out with the 2 in the denominator. So we are left with, let me just show that step as well, so that we're all clear. 4 minus b, so this after coming out becomes this 2, and then these two cancel out, and then we're left with b under root of 4 minus b, which is equal to the area. So that's the final answer. Something I'd be careful of, and I made this mistake myself before as well, is when we are calculating the area, I've taken the area of half of the triangle in the past, because when we're doing the Pythagoras, we're only considering, let's say, 1/2 of the triangle to find h in terms of another variable. So when I look at that, immediately when I calculate the area, I tend to use the base as b over 2, but since it's the area of the whole triangle, we need to use the base as b overall. So that's just the only thing to be careful about. Okay, let's look at the answer here. An isosceles triangle has 2 equal sides. Perfect. So the perimeter is this, and then we present the perimeter in terms of the length and height. So that's perfect. So that's what we had gotten as well. So hypotenuse equal to h square b square. Perfect. Okay. So the final answer is actually incorrect in this case, and I think the reason for that is 16 minus 4b. I see. So if you look here, this term should have been negative, because when we're calculating h, which is the height, it's actually the perpendicular term and not the hypotenuse. So that's why this equation is incorrect, and this should have been L squared minus B over 2 squared. So this answer is actually unfortunately incorrect. The height term calculated using the right tall. Let me just make sure I misspelled that. Theorem should have been square root L squared minus B over 2 squared instead of plus. Because of this error, the final answer is incorrect. Final answer should be area equal to B times square root of 4 minus B. Okay. So I think that's it for this question. We'll mark that as incorrect.